This video is dedicated to estimating adult literacy using Cycle 2 PIAAC data. You can check out the Google Doc here at this link, which provides a rationale for this work. If you're interested in formula and so forth, you can check out that technical report here. All right, so my name is Matthew, and in this video, I'm going to show you how to estimate the mean, the standard error, and the standard deviation for plausible values in the PIAAC dataset. Let's start with the script on line 22. You first of all need to obtain your dataset of interest, which is for your country. In this dataset, we use the Austrian data, but you can find your dataset at this OECD link here. The codebook associated with that data is here, and also the technical manual can be found at that link there. So in order to run this script and to estimate the descriptive statistics for plausible values in PIAAC, you need to probably put three important things into your into a folder, into a working folder. This is this R file, this R script, the dataset of interest. Here we've got the Austrian dataset in .sav form, which is SPSS form, and the codebook is also important to have as well to refer to. So once you've got those three files in your folder, you can then make a link between this R script and that folder. And you can do that via script and running script, right? In order to run script, you can choose Control Enter, I think, on a PC. On a Mac, we use Command Enter. So I'll be clicking Command Enter quite often, and you might hear this. Yeah, again. Okay, and that means that I'm running the script. It's the same as pressing run up here, but that's a little slow, right? So you can make a link via script if you know how to do that, or you can go to Session, Set Working Directory, Choose Directory, and choose that folder for which you have those three files already entered. We can double check the working directory. And we also need to clear the global environment of any other objects, like any other data frames or vectors or something like that, by running this script. Okay. Next, we're going to install three packages. The first package to install, if you need it, is the Pacman package. This is a package management package. Okay, it's really useful to have. So by running this script, R will install this package if need be. Thereafter, you can use that package, right? And the function pload to install those three packages here necessary for running this script. We have the psych package for descriptives, foreign for reading in SPSS data, and also HMISC for type of weighted descriptives. So we run this package, this package and function here, run this function here, and this might take some time to install. You'll notice the install happening down in the console down here. Next, we move to reading in the specific data set of interest, your specific country of interest. In this case, we're using Austria, and we're using the foreign package read SPSS function. So we can run that, and we can see that it's working now to read in that data. There's a few thousand cases and a few thousand variables, so it might take a little bit of time. Okay, here we have the data up here. So this is all cases and all variables. Notice that there's close to 2,500 variables, right? We can use the dim function of the base package to look at the dimensions of this data frame as well. You should also check the replication approach used, and you can do that by just running this code here, checking the structure of that variable, which is the replication approach, or the variable named VE method N. Okay, you can see that's important to note. We're going to talk about that a little later. I often run this script here, this basic script, in order to enable all output to be printed in the console. It's sometimes useful to do. Now we can start checking the variables. We can look at the summary of the first plausible value for literacy as an example. You should have some mean values and so forth. You can also check for missing data. We can sum the instances of NAs. In this case, there's no NAs. That's good. We can look at the structure of the literacy variable. It's a numeric, and it looks like we have all of the data points for all 4,565 Austrians. We can also use the describe function here to check out the mean for single plausible values. We can see that it's 257 for the first plausible value, and similarly 257 for the second plausible value. Col names function to check out all the col names in the data set. You can see them all here. It's quite a few, right? We can also check out, we can also describe certain columns of the data set. Actually, we don't need that. Okay. And we can see the plausible values specifically. We can see a description. And they're close to 256, 257. Okay. Today's focus is on plausible values, or this video's focus is on plausible values, but so we can quickly skip through this code here. It's not so important. We can actually just skip it. This is for the non-plausible value variables. Let's now focus on the full sample weight. This is SPFWTO. This is important for estimating the mean and standard deviation. Okay, we can see the structure of this data, and it should be a numeric. It is, and there's no problems here. Let's also look at the final replicate weights, 1 to 80. We can check out how many you have. There are 80 in this instance. You can run this code to check how many. We can look at the first instance. We can also describe that as well. Okay, it should be a numeric. It is. Excellent. Number of replicate weights. There are 80 for this, right? We can also identify the column where the replicate weights are in the data. And we can see columns 2416 and 2495. Okay, so we can also describe that as well. Okay. All right, so let's now move on to the main focus of this video, which is estimating adult literacy using plausible values, right? So remember, this is our data, and we want to work out the position of those plausible values in that data. So we can do that by running this code. And this gives us the position, the columns for which the plausible values exist. Similarly here, this is all of the full sample weights and the replicate weights, and all the positions. There are 81 positions here, 81 column positions. Finally, we can see the number of replicate weights is n. So this gives us some information, right? This gives us vectors of information about which columns are important in this data for this analysis. We can now apply that and create a new data frame which only includes the columns that are of our interest. We run that code and we check out the dimensions of the new data set, and we have 4,565 cases and just 91 variables now. So now it's easier to work with. Let's now move on to, I guess, how to deal with missing values. In this case, we're just going to use complete cases. You might apply another type of missing value analysis or some type of imputation, but in this case, we're just going to use complete cases. So whenever I do some type of potential reduction in data, I often use dim before and dim after just to check on the shift in the number of rows as a consequence. Here, there's no shift because we have complete cases, which is good. Okay. So here are our call names for this refined data frame that will help us estimate the mean and standard deviation for literacy for Austria. So in this data frame, yeah, we've got these important columns here. The first 10 columns are the 10 plausible values for literacy. The next one is the final sample weight, and then the next 80 are the replicate weights. So now that we have DF defined, we can now move to creating functions to apply to DF. First, we need to focus on the constant, and the constant will depend on the country. And I mentioned that up here before. You need to check on what type of method is used. So for here, generally it is the constant. You can just use this number here. That will work fine. If it's France, then it uses another type of constant. Now, to generate the functions, we run this code here. And this function is saved up here. My function, plausible values for the mean. Next, we run this function here. We'll save this function, which is my function, plausible values, standard deviation. You can check all the functions and the loops and so forth here, which correspond to the formula here. Now, for this data frame, we want to know the positions of certain variables. So again, we can just run this code to identify the positions of the plausible values in the DF data frame, and we can see it's the first 10. Next is the position of the final full sample weight, which is column 11. Next are the positions for the final replicate weights. We can see those positions here. With these positions defined, we can run the function with these 3 arguments. We can run the first function for establishing the mean and standard error. We can thereafter run the next function for estimating the standard deviation. We can print the results. we can print the rounded results. So the mean plausible values or mean literacy for Austria is 254.37 with a standard error of 0.88. So remember, plus minus 2 standard errors gives us our 95% confidence interval. Similarly here, we have the standard deviation, the estimate for the standard deviation, and we also have plus minus 2 standard errors for the standard deviation too, but this isn't really often reported. So basically, you can just report the mean and standard error and also the standard deviation as well to 2 decimal places. And that is it for this video. And remember, this video was for estimating adult literacy. You can obviously estimate the other forms of literacy as well using the same methodology. I hope this helps. And if you have any questions, you can put them in the chat. Thank you so much.